All right, welcome back, you guys. We're going to talk about a graph of a linear function. We're going to find the slope. We're going to describe the slope of a horizontal of horizontal vertical lines. We're going to find x and y intercepts. We're going to find the slope and the y-intercept from the graph, and then we'll find equations of horizontal and vertical lines as well. So last time we talked about, we did it with some point plotting and table of values, and that can be helpful for this section, but we're going to do specifically linear equations. Linear equations are anything of the form y equals mx plus b, where m is your slope, b is your y-intercept. And the slope m right here, that is the steepness of the line. So if you have a line, let's say like that, you might have a slope of 7, compared to a line like that might be a slope of 1/3. But either way, both of those slopes are positive if they're going up and to the right. If you have a line going down and to the right, your slope will be less than 0. Your slope will be negative. If you have a slope that's perfect, a line that's perfectly horizontal, your slope will end up being 0. And finally, your last scenario, if you have a line that's perfectly vertical, your slope is undefined. Okay? So, let me erase this real quick. The steepness of the line, the slope, is found by seeing how fast it rises or drops. That's your vertical change over how much it runs. So, or in other words, your change in y over your change in x. Or when you have 2 points, in other words, change in y is the y2 minus the y1 over the x2 minus the x1. So with a picture, say we have a line that's a positive slope here. And let's say we have these 2 points on the line. So if we know this, which is, here, let me label the points, x1, y1, and x2, y2. This change right here is your y2 minus y1. That's your vertical change, the difference between those two y values. That's your numerator of the slope. And it's divided by x2 minus x1. That's your horizontal change. Again, that'll give you the steepness of the line when you divide those two. Well, let's do a couple scenarios here. First example, find the slope of a line using the given information. So if we have a line that runs 16, rises 16, sorry, and then it runs 4, so it goes up 16, and then it runs 4. I go up 16, I'll do it over there, and then it runs 4, so up 16 over 4. Slope is rise over run, so that is up 16 over 4. Then your slope or steepness is 4, or simplifies to 4. In other words, 4 over 1. In other words, it rises 4 for every 1 over as well. Right? It's the same steepness there. Now, if you're given 2 points, you want to use those 2 points to find the slope. So in this case, we have 4, 9, and -3, -7. 4, 9, -3, -7. So you notice this line goes up and to the right. So since it goes up and to the right, is the slope going to be positive, negative, 0, or undefined? So we can name the points. So we can name them x1, y1 is x2, y2. And it doesn't matter which one you do. I could have done -3, -7 as the x1, y1, and 4, 9 as the x2, y2. But then we're just plugging it in. So our slope is y2, which is -7 minus, so -7 minus the 9 over x2, -3 minus 4. So my slope ends up being -16 over -7, which is negative over negative is a positive. So our slope is 16/7. Now, second one set of points here, we got 3, -3, and -6, 3. So notice this slope is going down to the right. So down to the right, is it going to be positive, negative, 0, or undefined? Good, good. Let's see, that's exactly negative. So let's go ahead and name it x1, y1, x2, y2. And you just plug it in. So our slope y2 is -3 minus the y1, which is just a 3. x2 is 3 minus the x1 of -6. So we got -6 over 3 plus 6, which is 9. So our slope, and both of those divide by 3, -2/3. So our slope obviously is negative again, right? -2/3. Well, let me have you guys go ahead, pause it here, and do that third one on your own. Hopefully when you guys see on this one with a perfectly horizontal line, hopefully you notice, hey, that slope is going to be 0 for a horizontal line. And of course, you can always check it like you guys did with the equation here. So the slope ends up being -8 minus, and then y1's -8 over 2 minus the -3. So we got -8 plus 8, 0 over 5. So our slope, 0 divided by anything? 0. Thanks for your work on that, guys. All right, how about intercepts on a graph? X and Y intercepts. So when you're finding, let's talk about x-intercepts for a minute. Let's say I have this crazy curve. We're not going to deal with this right now, but notice all of these points, which are x-intercepts. They cross the x-axis. What do all these points have in common, you guys, that cross the x-axis? So when you're finding x-intercepts, the y values are always 0, whereas when you find the y-intercept, here's the y-intercept right here in red. When you find the y-intercepts, crosses the y-axis, the x value is 0. Okay, so that's what we're going to use. That information is what we're going to use for lines as well. So this one we've got 3x plus y equals 3. And I know you don't have a picture of it right now, but this is kind of what this thing looks like, you'll see. But in order to find that point and that point, what we have to do to find an x-intercept, we let y be 0. To find the y-intercept, we let x be 0. So let's go ahead and find the x-intercept first by letting y be 0. So here's our equation. We're going to let y be 0. And we're going to solve for x. 3x equals 3. So x equals 1, because we're going to divide by 3 on both sides. So 1, 0. So I actually drew this wrong, didn't I? Get a better picture here. That's not good. In fact, we'll draw it in a minute here after we get our x and y intercepts. So we have the point 1 comma 0. Now let's do the y-intercept by letting x be 0 in the equation. So let x be 0. Well, 3 times 0 is 0. So it looks like y ends up being 3. When x is 0, y is 3. So I have the point 0 comma 3. Yeah, these are my 2 points on the line. Notice I have a negative slope there. So I have the point 1, 0 and 0, 3. You only need 2 points for a linear equation to draw the line. Let's do that. Do that next one here. Once again, to find our x-intercept, let y be 0. To find our y-intercept, let x be 0. So let's find our x-intercept first by letting y be 0 in the equation. 5x minus 2y equals 20. We're letting y be 0. So we got 5x minus 0 equals 20. Divide by 5, we got 4. So 1, 2, 3, 4, comma 0. There's our x-intercept. Now let's find our y-intercept by letting x be 0. So 0 minus 2y is negative 2y. Divide by negative 2, y ends up being negative 10. So 0, negative 10. So here, and it's going to go through both those lines. Whoops, I didn't draw that very straight. It's going to have a positive slope, and there's our 2 points for the x-intercept and the y-intercept. All right, our last one, we got y equals 4/3 x. Again, to find our x-intercept, let y be 0. Find the y-intercept, let x be 0. So let's find the x-intercept. We're letting y be 0. And how do we solve 0 equals 4/3 x? How do we get rid of that 4/3? We'll multiply it by both sides by 3/4, the reciprocal. So 4/3 times 3/4, see how that's going to give you 12 over 12x. In other words, 1x. That's what we want, right? And 0 times anything is just 0. So x is 0 when y is 0. X is 0 when y is 0. Well, if we find the y-intercept by letting x be 0, find the y-intercept by letting x be 0, notice y ends up being 0, right? It's the same point. So they hit at the point 0, 0. So the problem with this is they both hit at the origin. That's the x and the y-intercept is right there at the origin. And so we need a little more information in order to write, to draw it, to graph that equation. And so what we'll go to is we'll start talking about y equals mx plus b. And so let me go ahead and erase that. This is a good problem to do that with. So any linear equation can be written in this form: mx plus b. M is our slope, and then b is our y. That's actually our y-intercept, is the b. They call it the b for some reason. So this case we have y equals 4/3 x. Notice my m, my slope here is 4/3. And my y-intercept is 0. So when you're graphing these, the first thing is you do the y-intercept. B equals 0. So that's the y-intercept. Well, if the y-intercept is 0, where it crosses the y-axis right there is 0, right? That's the point 0, 0, in other words. So you put that line on the graph first. And then the second thing you do is you use the slope. So, well, we know the slope is rise over run, which in this case, it's the number 4/3. Rise means we go, that's the up or down. If it's positive, we go up. If it's negative, we go down. Well, this is a positive 4, so I'm going to go up 4 from the y-intercept. 1, 2, 3, 4. And then run is the horizontal change. That's the right or the left. Well, this is a positive 3 on the bottom, so I'm going to go right 3 from there. 1, 2, 3. And I put a dot there. And that is the graph of y equals 4/3 x. It has a rise of 4 and a run of 3. It has a 4/3 slope and a y-intercept of 0. Let's do some more like that. Here's the next one. Y equals negative 3x plus 2. mx plus b. So number 1, our b is 2. That's our y-intercept. So it crosses the y-axis. Y-intercept crosses the y-axis right there at 2. In other words, this is the point 0, 2. So you graph that point first. You graph the y-intercept first. You got to have a point on the graph to start with. And then our slope, rise over run. In this case, see how the slope is negative 3? It's negative 3. Well, the denominator is 1. So put that over 1. Negative 3 over 1 is the same thing as negative 3. And since it's negative 3, I'm going to go down 3. 1, 2, 3 down. And the denominator is a positive 1, so I'm going to go right 1 from there. Right 1. I'm going to put a dot. And then I'm going to draw the line. Have a negative slope. Down 3, right 1. You can always punch that into Desmos and check it, right? Let's do a few more here and we'll call it good. So second one here, we got y equals 3/4 x minus 2. Again, notice it already has y solved for. And so my b is negative 2. My y-intercept is negative 2. That's the y-intercept. It'll cross the y-axis at negative 2. In other words, it's the point 0, negative 2. Put that dot on there. And then number 2, the slope. See how the slope here is 3/4? So slope is rise over run. And it's 3/4. Well, it's a positive 3, so it's going to go up. If that was a negative 3, it would go down. And there's a positive 4 in the denominator, so that's going to go right. So we're going to go up 3 from the y-intercept. 1, 2, 3, and then right 4. 1, 2, 3, 4, and I'm going to put a dot. And I'm going to graph it, and I'm going to miss both points accidentally. But there you can see y equals 3/4 x minus 2. Now in this third one, 5x minus 2y equals 40, you're going to notice the y, it's not in the y equals mx plus b form. You know, you got to have it in this form in order to graph it with this approach. 5x minus 2y equals 40. So the first thing is, well, I got to solve for y. So let's get rid of this 5x. So I got negative 2y equals negative 5x plus 40. Now divide everything by negative 2. Both sides by negative 2. So I got negative over negative is positive. 40 over negative 2 is a minus 20. And now I say, oh, there it is. Y equals mx plus b. So b, number 1, the y-intercept is negative 20. So that's the point 0, negative 20. Clear down here. 0, negative 20. And then the slope is 5/2. Slope is rise over run. Positive 5 over positive 2. So positive 5, I'll go up 5. right 2. 1, 2, 3, 4, 5, and right 2, and I put a line, put a point on there, right? And I should mention as well that if you go up 5, right 2, that's actually the same thing as, isn't a -5 over a -2? That's the same thing, right? So I could actually go down 5 and left 2. The problem is it's off the graph. You know, it's way down here, but I don't have room to go down 5, left 2 from the graph, or from this plotting that I've done here. I just didn't leave myself enough room in the window. Okay. All right, we got one more here. All right, this last one, we got 24x plus 4y equals 16. Again, it's not in this form, y equals mx plus b, so I got to solve for y. So let's get rid of that 24x. So 4y is negative 24x plus 16. Let's divide both sides by 4. So we got y equals negative 6x plus 4. And there it is, mx plus b. So it looks like our y-intercept is 4. That's our y-intercept, crosses the y-axis there. So that's the point 0.04. And then our slope is negative 6. So number 2, our slope, let's rise over run, is negative 6. So put it over 1. Negative 6 over 1, same thing as negative 6. So negative 6, that means it'll go down instead of up. It's a negative. Positive 1, I'll go right. So from the point 0.04, here's the point 0.04. I'm going to go down 6. 1, 2, 3, 4, 5, 6, and then right 1. Right 1. And I'm going to put a dot. So down 6, right 1. Again, I'd be remiss if I didn't say 6 over negative 1 is the same as negative 6, right? So I could go up 6 and left 1. If I went up 6 and left 1, I'd still be on the line, right? Up 6 and left 1. Okay. And then, of course, always a good thing, do it by hand, and then you can check that in decimals. So let's go ahead and do this last one by pulling up decimals. Let's see here, desmos.com. Go ahead and pull up that graphing calculator. And we can punch in 24x plus 4y equals 16. And there it is, which, by the way, is the same as we solved for y. And that was y equals, what was that, negative 6x plus 4. And notice that's the same line, right? The blue went over the red there. And graph that for us, but had that was their y-intercept 0.4, and we went down 6 and right 1. So we have that point right there. Oops, I can't get on there. Well, if I want to get the points, I go like this. 0.4, and then we went down 6, right 1. So I should have negative 2. Oh, sorry. 1 is my, there we go, 1 comma negative 2, right, was my other point. When I went down 6, right 1. That's the point 1 comma negative 2. Well, thanks so much for watching. See you guys next time.